learn about Azure virtual machines. So let's get started. So in Azure, we have a different type of storages are available. So how are we going to configure the storage? How are we going to configure a block type of storage? And how are we going to apply the security, whether it's a SaaS key or managed identity or so on? And how we can, excuse me, how we can use Azure files to do the file shares and other file sync. Great. So storage account. Storage account is it's a part of the Azure storage. So when you actually create a storage account, you can use that storage account to store multiple different type of storage. Also, you can run the multiple services on top of it. So we're going to explore different storage services, different storage kinds, types, replication strategy, and how we're going to access the storage, whether it's going to be a public, private, and so on. And how we, when we need to access the storage, how do we do that? So it's using the endpoints. And let's have some demonstrations on that as well. So the service that you can use to store files, messages, tables, and other type of unstructured storage. So if you can just say structured and unstructured means there is a table is more like a structured data, isn't it? And unstructured is it's a random. There are no pattern or the structures are followed. So this is how the storage needs to be accounted for a different type of data storage or the file storage or document storage. So Azure storage is also it's really durable, secure. It can be scaled and managed, also accessible. And the storage for the virtual machine can be done through that as well. The other scenario is if you want to store Docker images or virtual machine images, you can use the Azure storage for that as well. There are 2 tiers for it, premium and standard. And you need to choose the right storage tiers for your requirement and need. So these are some of the type of Azure storage service, containers, tables, queues, and files, and it has different purposes. So if it is a container, it's a massively scalable object store for text and binary. So the binaries are like videos, audios, documents. Document can be images or some sorts of PDF files and so on. And those are the more like a big data or backup files or database extracts or logs or anything. Those kind of storages, those type of records you can store using the blobs. And if you like to store more like a table structure or entities, then you can use table storage. This is not likely RDBMS, but this is a type of a storage where we want to have low latency connectivity to a certain type of data. We can use for queues as well. It's a messaging store, and it's a reliable messaging between applications components or even your client side of application and server side of application, or you actually monetizing your data. You can also pass through the queues and pass those notifications back to that. So images to download or images to resize and so on, those kind of notification, if you want to pass through the queue, that you can do that. And the files typically designed to store file shares. So typically we used to have on-prem file storage from the NAS drive or some other file storage server. It's something similar, but at the higher scale and in depth, even better, more secure features are available through the Azure files. You can define the shares. You can also put that share on premise deployments as well. And you can allow your users to share their files. So what are the storage kinds? So we understood about the standard general purpose type of storages. currently many of you probably might be in version 1. So it is recommended that like it should be upgraded to version 2. So most scenarios like blob, file, queues, data lake is another one. So that's a kind of a storage you can do using a general purpose V2. Block blobs, where there is a storage low latency storage consistency you need, then block blob scenarios can be covered using this storage. File share, as name suggests, but it's more like enterprise and high performance file share. And page blobs are high performance, again, a blob scenario. So these are the premium features and the standard features. So you need to look at based on your requirement. Say if I like to have a file share to be implemented, then this is a premium file share is one of your selection. It can go into like a different blob storage as well. If it is a standard, there is no need for the premium selections, a premium type of services. When we actually replicating storage data, there are different type of options are available for your redundancy and making sure reliability. So let's try and understand a little bit on this one. So LRS is a locally redundant storage, and as the name suggests, it replicates the data 3 times within a single data center. And it provides, I think, about 11 nines. So the reliability or the SLA, we count in nines. So it starts from like the 2 nines to goes on like 17, 18 or some other big numbers. So particularly LRS is 11 nines. That means your services will hardly ever go down. And there's a table for it. If you have learned in AZ900, it describes a table of content that what does that means in seconds and minute, how much it's allowed per month to go down. And it's very, very low. So it's always reliable to go ahead with that redundant storage option. And LRS is like very lowest cost replication as well in compared to the other ones. So it can be used. So if your requirement is to keep your data in a local region, one single region, no issue about like region failure or zone failure, and if your business is not affected by those kind of scenarios, then LRS is a good option. The second one is a zone redundancy, redundant storage. As the name suggests, it replicates again 3 replica. It keeps it. It also keeps into the 3 different zones within one region. So in LRS, what happens is it keeps the data into one zone, and if the zone fails, you got problem. If region fails, you got problem. So you got a downtime there. But when you go with a ZRS, if your local one of the zone fails, you secured by having this replication. So you got Z1, Z2, Z3 is just a naming convention we use. So if the Z1 fails, you still have Z2 and Z3 available to serve the purpose. But if the region fails, then you haven't got any protection against that. So to protect even further, I would go into the GRS, so which is geo-redundant storage. And there is a read-only geo-redundant storage. So we'll talk through about this one, what are the difference between two, but it's typically the name suggests that. Now, in GRS, it actually keeps 6 replicas in 2 regions, so 3 per region. Now, if your zone fails, you are protected. If your region fails, now you're protected as well. Because if the one region fails, the other region kicks up. That there's a rule for it. These 2 regions, the distance, the physical distance, it's greater than 300 miles apart. Why? Because if, say, any kind of natural disaster happens, probably earthquake, flooding, or fire, or anything happens in one region, it's like the other region becomes more secure, it's available there to solve the purpose, because that's a more than 300-mile distance, and this is how it's protected. So in this one, there is one thing I would like you to notice here. So LRS protects against disk, node, rack failure. So this is a typical scenario where you want redundant storage against this kind of failure. But if it is like ZRS, then you definitely have all the features like LRS, but you also have a zone failure. So let me just highlight this. So you got this one section here. So it protects against disk, node, rack. ZRS protects against disk, node, rack, and zone, where GRS protects against major regional disaster. So it also covers all three things. So disk, node, rack, also zone, and in region as well. Okay. So it protects against all of this. So it's compared to GRS and read-only GRS, the difference is typically it's a read access to secondary region only. So that's the one of the difference here need to understand. So it's a separate secondary endpoint as well, and recovery point objective RPO delay to secondary can be queried. Yeah. So this is like one of the feature it provides with the read-only. Okay. Now we also have another two more additional options, which is GZRS, which is geographically zone redundant storage. What happens, say your one geography, like say example, my data center is in Europe, which is North Europe. It replicates with the GRS to say East Europe or West Europe. But let's see, if the connectivity or major disaster happen on that region and both of the regions are not available, then you can typically go into multi-region. Might put down say UK North or UK South, and which pretty much both type of region follows the similar data governance policies. Then it just makes a lot easier for me to replicate those. So what this done that does provide GZRS is 6 replica, 3+1 zone, 2 regions, and protects against everything like disk, node, rack, zone, region failures. And then I have again read-only option. The separate secondary endpoint, and that's a read access to the secondary. So why would I do that? It just works out a bit of cheaper cost in terms of when we're having a read-only access and not to worry about the sync. But say for example, if I have this secondary region kicks off as read-only, and now I got this zone to be recovered. So while my users are accessing this data, I don't need to worry about data to be synced back. So that's how this is another use case which I can use for the read-only. Access storage. So this storage are accessed using URL-based address. So typically the blob storage has a blob in between here, blob, then core.windows.net. It's your standard domain name. This kind of question you do get to try and remember what that means here. So it's very simple. So it just if it is a container service, it says blob. If it is a table service, it says table. If it is a queue service, then it says queue, and the file service says file. What is in front of here is the storage name you have given. So when you're creating a storage account and the name you have given, say my company photos or my company images, then it's just https:// my company images .blob.co.windows.net. And this is how you can access. So here is a example given for the custom domain pointing. So typically you created a blob called Contoso blobs, and that's where you're storing all your images, videos, files, and everything. And you want this to be accessed on the website. Typically it's fetching the data, but you don't want to show this particular name, then you can use a custom domain, and that custom domain can be like a subdomain I've created, and that subdomain will have a CNAME record, which I can change target to this URL, and it will work. Okay, so we need to secure this storage endpoint. So we can literally select from multiple options here, like, so enable from all network, or we can say enable from selected virtual network and IP addresses, or we can just literally disable, say, no, I don't want to give access for the outside services. So that's something we can do. And you also have option to network routing, whether it's a Microsoft network routing or internet routing, you can select that. Okay. We'll skip the demonstration for now. We will have all the demonstrations together for this section. So how we configure the blob storage. So the blob storage, you can start creating as an account first, and then you go into the blob section, and that's where you can start creating other containers, different containers. Each container typically, so this is your blob account, and you create multiple container different with the different purposes. And once you create that container can have a different type of options, whether it's anonymous or it's going to be a protected one, which is a private one, and there are other options as well. So this is how you can distribute the e-messages, like, just one typical scenario, but you can have a different scenario based on your requirements. So common use cases, serving images and document directly to your browser, storing files for distributed access. Example, your sales team would like to store all the brochures and product brochures and circulate it as and when needed along with the quotation. Then it's typically you can maintain it here. Streaming videos and audios, that's another use case. Storing data for backups and restore, disaster recovery and archiving purposes. So there are different tiers we will learn about, like, when to use archiving and when to use a different tier for, like, this kind of real-time accesses. So that we will learn. And then storing data for analysis by an on-premise or Azure hosted services. So if you want to do further analysis, you can do that. Why would I use this storage account to do all this tasks? Because one, it's got the highly reliable, it's got about 11 nines, as I said, for the blob. And also, like, it's a low cost, so it works brilliantly. So as I said, the containers can be created underneath the account, and you have a 3 different options, whether you go private, no anonymous access, and you go blob, which is anonymous read access for blob only, or you go container, which is anonymous read access for containers and blobs. So this is how you can do that. The blob is typically those files or documents which we have uploaded. So you can just select, like, as you typically like. So if I just give a quick scenario, say, why would I select blob anonymous read access for blobs only? So let's assume that I'm uploading all the images for my website. I'm operating e-commerce website, and there are lots of product images. Then I can have the read-only access to the blob and point, like, pick all these images URL and put it into my e-commerce website. For normal user to go and access. But let's assume that I have a very secure files I need to upload. So my customers logs in and they provide certain ID and I need to store it. Then I typically use private for the more security. How would I access it? Then you need to actually provide the authentication to actually go through the authentication layer along with a SaaS key. You can also use managed identity to access those blobs. So your application and the blob talks in that way. you can even go further by implementing like Azure B2C and something, and then pass those tokens back to the storage and say, okay, can you authenticate me? I'm a Mr. John Smith accessing your website, and I'd like to access my own document. In that scenario, you can just establish a private access because they have a secure document, but also authenticate using Azure B2C. So these are the different type of options that are available for container. The tiers, like tiers are, there are 3 different tiers. One is a hot, cool, and archive. The main difference between 3 is obviously the type of amount of access we want to do, or how many times you're accessing file. That is the main importance on this one. So hot is typically optimized for frequent access. Remember, this is for the frequent access for any objects or any storage accounts we have done. Where it comes to the cool tier, it's, remember, at least like infrequently accessed and stored for at least 30 days minimum, then it's more effective. And archive is like several hours of retrieval latency and will remain in the archive tier for at least 180 days, then you use this tier. So if I'm archiving all my files and needs to keep it for data retention policy perspective, I would use this archive tier. Okay. The blob lifecycle management rule. So we can set up those rules, and we inform that, like, okay, based on the modified date, and I want to say, like, okay, this file never been modified. I want to move from hot to a different tier. So then typically I can say, okay, based on this, how many days ago, if it is a 6 month or more, or 12 months or more, or 24 months, or like, based on that number of days you calculate, then move to cold storage. Because it's infrequently accessed, then why would I use that resources from the hot tier? Or you can move from archive. You can write a rule says, okay, if it is anything 5 years, 7 years older than that file, I don't want to keep it into the system because it's not going to be used, then I move it to archive. Or simply say, okay, this is more like a 10 years old file and there is no significant importance of this file, then let's do the delete the blob. So it automatically manages this rule. Okay, blobs object replication, which is it's an asynchronous service. Also, a minimum latency is available here, so we can have like a one blob into a container into region 1 and the container into region 2. I probably do this kind of replication if I'm operating in a multi-region, multi-country operations, and where I want to make sure like the blobs are accessible by my user who are more closer to that. And it optimizes the cost, optimizes data distribution, and it increases efficiency for compute workload. Okay, so we can go into the demonstration in the next sections. Let's do and work like discuss about the storage security. So in a storage security, we can secure that. So by default, it comes with the encryption, and you can configure whether it's TLS 1.1 or 1.2. Obviously, you need to select those kind of encryption, HTTPS endpoints, and so on. Authentication with Azure AD or Azure AD B2C, and then you can use RBAC rule as well. You have those client-side encryptions. You have disk level encryption. You got SAS key, so shared access signature, which you can allow that. Shared access key has a life of 24 months is a maximum, so you need to be mindful of you need to rotate those keys. The keys are encrypted signature string and can be used along with key vault. And you can have anonymous access to the container and blobs. So when you create a shared access signature, this is the example. So you create a key, you give the permission to the key, and also you give how long it's going to be the valid for. So you need to give that start date, when to start the validity, when to expire, and what are the allowed IP addresses and the protocol. Typically, we always remain on HTTPS. So make sure you do that selection. And this key can be used into the different application to access the blob storage. Okay. URI, like SAS key can be passed as a part of URI to access this blob. And that's why at somewhat in some application, you might consider as a little bit less secure. So what happens is you got the blob, which is URL here. You got all the relevant parameters here. And this is where you got signature, SIG. So that signature you pass into URI and you will be able to access it. Okay. So we'll skip the demonstration. So the encryption level, we have managed keys or the customer managed keys. So Microsoft also provide the managed key, which you can use it. But if you want to use your own key to encrypt data, you can always upload that. So what it does, it protects your data for security and compliance. It also automatically encrypts and decrypts your data. It encrypts through 256-bit AES encryption. And it also enables all new and existing storage account and cannot be disabled. Once it's enabled, is there. Is transparent to user, so it can be easily accessible. When you create a customer managed key, which is your own key, what you do, you select the customer managed key here, and you provide key from the key vault. And that's where you assign which key vault, which storage key you want to assign, and you actually create that key within the key vault. So it becomes even more secure. Okay. So the best practices for the storage security, always use HTTPS and create a distribute and access SAS key. So you're given the SAS key to certain applications to use that. Then you can also rotate this key on demand as well. So it's you don't have to keep it for 24 months. It's a recommended period by Microsoft is 6 months, but in many applications, in real life application, what we have implemented is just expires within minutes, and we generate that new key again programmatically and apply that again. So that is even more secure. So if it is the key is mentioned in the URL, next time when you try and use that URL to access that blob, you won't be able to do it. But let's assume that you still wants to keep it secure using a SAS key to give the access, but this images or the the documents are public domain, then you don't need to keep rotating it. Reference stored access policy where possible. So policies will perform those all your restrictions and requirements here. Use near-term expiration time on an ad hoc SAS. You can use use storage analytics to monitor your application. What is happening? Is there anything problem? It's not something is not right. You need to try and monitor and make those amendments as quickly as possible. Be careful with SAS start time, because when you actually define, it's going to start from there just after that, time pass. So just be careful when you give grant and when you actually expire that key. Be specific with the resource they need to access. Understand your account will be billed for the usage. Yeah. So every time you use, your account will be billed. And you need to validate data written using SAS. So that is another layer of best practice. And don't assume the SAS is always the correct choice. So as I said, SAS is can be less secure in many scenarios. So it's just not, don't do that assumption and opening up the SAS key for 24 months and you forget. And then also you need to recycle that after some time. So that maintenance also